Prediction is the most commonly used application of AI and machine learning in business today. What are the 4 steps that go into creating a prediction model? How can we use more than one piece of information or one feature to make a prediction? These are 2 topics that we'll discuss in this video, and then we'll go talk about one of the most important applications of AI and machine learning: forecasting sales or predicting sales. We'll talk about how that works in stores and in platforms and in other types of businesses and in hospitals and energy companies. Welcome back to Jay's Intro to AI. This is the second video. In the first video, we talked about prediction, about making an estimate based on existing historical numbers that we have. And we discussed an example of an ice cream shop. It looks like this, and we said, if we had 3 people who walked into an ice cream shop, how much would they end up paying? To answer this question, we said, okay, there are 4 steps in the high-level prediction recipe. Let's say this is vastly oversimplified, but it's important to know. So first, we decided what we want to predict, right? And that is the dollar amount of the transaction. And then when we want to make a prediction, the second step would be to prepare the data. And that would be collecting the data, would be getting it from different places, merging it, visualizing it, transforming it in different ways. And this is really the most important part of this entire process. And a lot of the time and effort and know-how really go into this second step of preparing the data. Sometimes we're not able to find the data that we want to make that prediction, and so we need to decide on something else to predict. But then once we have enough data and we've analyzed it enough, we can start experimenting with models. And we start creating prediction models and we evaluate them. Maybe we end up with good models, maybe we don't. And if we don't, we have to go back to the data stage and work on our data, maybe transform it in different ways that enable the models to make better predictions. And it's very common when you're working on models to go back and work on the data a little bit more before you're able to come up with the final prediction model that is able to solve your problem. Once we have a model that we like, we can roll it out and start allowing it to make predictions. And so this is a very high level, vastly oversimplified recipe for making prediction models. After some time, maybe we gather more data, we can train the model once again, and then roll it back out. Now let's look at how we use this prediction recipe in our ice cream example. And so we said we wanted to predict the dollar amount of the sale, of the transaction, how much ice cream or how much money would we generate from these people, the group of 3 people walking into an ice cream shop. We prepared data, and so we said, okay, let's look at the previous 3 examples that happened in this store. There was a group of 1 person who purchased for $10. There was a group of 2 people who purchased ice cream for $20. And then there was a group of 4 people who purchased ice cream for $40. Now, we have never seen a group of 3 people walk into this ice cream shop before, and so we asked ourselves, despite that we've never seen a group of 3 people, is there anything we can learn or infer from this data set that allows us to make a guess or an estimate or a prediction of how much a group of 3 people would pay? And so this is an intuitive question, and it's an easy data set, and we said, okay. So the green column, which is called the features, is related to the pink column, which is the label. And this relationship can be explained by the number 10. So whenever we multiply any value here by the number 10, this is a simple relationship or pattern that we found between these 2 columns. And so we can say, okay, we can come up with a prediction model that just takes in a feature, multiplies it by this weight, the value of 10, and then that is the prediction. And so this is the model training process. The training is just coming up with that proper weight that explains the relationship between the 2 columns. And so now we have a prediction model. We pass it the number 3 as input. It multiplies 3 by 10, and it makes a prediction of 30. And so these are the 4 simple steps of the prediction recipe. This is how we looked at them in the first video. And in this video, we'll take them one step further to incorporate multiple features. And so let's change our example a little bit more. Let's say this. Let's say we have a group of 2 adults and 1 child. How much would they pay? And so we still have the same first step, what to predict. We're still predicting sales. But then we can look at the data a little bit differently. We can say the previous 3 transactions in this same ice cream shop, how many adults were there in each group and how many children. And here we can see that the first group had only 1 child, ended up paying $5. 1 adult paid $10. 1 adult and 1 child paid $15. Is there a way where we can find to map this relationship? And this is a data set that's, again, vastly oversimplified just to make the main concepts. And when I ask this to people, generally they're able to come up with the answer. It seems that children usually buy for $5 and adults usually buy for $10. And so that is our prediction model. We assigned a weight to each of the columns that we have, and so we can start to make predictions. How do we make the prediction in this case? We have feature number 1 is number of adults, and then feature number 2 is number of children. We pass these to the model. Each feature, we multiply it by the weight associated with it. So we say 2 times 10 is 20, 1 times 5 is 5. We add those up, boom, that is our prediction. 25. And that's a simple way of saying, okay, we can extend our model to any number of columns. We just assign a different weight to each column. And in the training process, we are able to find that those weights that explain this relationship in our data set. Notice that this is oversimplified in a number of different ways, right? So some of them is that this is a very clean data set. In the actual world, data sets are not this close cut. So you would find that different children walk in. Some of them would pay nothing. Some of them would buy for 10, would buy for 8, would buy for 3. But it's always good, I find, to start from somewhere simple and then build up the complexity, and so on and so forth. So now that you know how to do 2 features, you can use 4 features, and you can take a data set of predicting the prices of houses based on the area, the number of bedrooms in the house, the number of bathrooms. Maybe you want to calculate distance to near schools. You just assign a weight to each column and you make a prediction. And so this is one of the simplest ways to make a prediction model. And it's extremely powerful and important, and it's called linear regression. There are vast number of other models, but this is a really good place to start. And a lot of businesses can benefit tremendously just by using this. And it's a great model to start with, because I wanted to build an understanding for a simple model, so you know the other parts of the recipe, and then you can move on to more complex models if you'd like. Now that we've covered the prediction recipe, and we've looked at how to use more than one feature, up to thousands or millions of features to make predictions, let's talk a little bit about the business application. And I'm selecting these applications that I'll be talking about in this video and the upcoming videos, trying to make sure that they're useful everywhere in the world and in every country as much as possible. Because if you look at machine learning, there are some applications, some problems that are only useful in certain places, or you have to get a PhD to be able to use, let's say, machine learning to detect cancer or solve some of these problems. So we've looked at the ice cream shop, and we say, okay, it's a store selling something to buyers. So we have seller side and a buyer side, or a supply side and a demand side. Let's say we start the week with only 3 scoops of strawberry ice cream in our inventory. Now, what happens if during the week customers demand 6 scoops? We'll be able to satisfy the first 3. And then for the other 3, we'll say, we're sorry, we're out of strawberry ice cream. And so we'll not be able to sell them. Some of these customers will switch to another flavors. Some of them, we just lost the sale. And so this is a business problem called understock. And so we did not have enough stock of the item to satisfy the demand of the customers. And so that resulted in lost sales. If we had somebody working on machine learning for us at the store, and they say, okay, let's look at the historical record of sales that happened in the store, and then they predicted that this week we'll sell 6 scoops of strawberry ice cream. And based on this, the business went out and stocked more ice cream. So they had 6. They would be able to increase their sales, right? Because they were able to satisfy the demand that was predicted accurately. And so this is one way that is important for you to know of how machine learning is useful for businesses. By predicting demand, you can increase sales and make more revenue. This is important, and this is a very powerful idea. I want you to be equipped by the power of knowing how to use data to make predictions and to deploy AI and machine learning. But also, you need to understand where that is creating value for businesses, because understanding the intersection of these two, you'll be able to develop your skills and potentially, start businesses that solve these problems to various companies. So it's very important for you to realize where the value is being created by machine learning application. In this case, it was to increase sales. And we'll look at another example that is actually a lot more important. So ice cream, you can store ice cream for months or years maybe, and it will not spoil. But what about milk and dairy and cheese? Let's say we start the week, we're a grocery store, and we have 3 bottles or gallons of milk. And then at the end of the week, only one of them is purchased. That's the only amount that buyers wanted. What do we end up with here? So we had 2 bottles that were not sold, and so we had overstock. And so we lost money. We wasted shelf space, and we, maybe purchased this, and either us or the dairy company is losing money on this unsold because at the end of the week, it's spoiled. Milk does not live forever. It will spoil in 4 or 5 days. You can say the same about a lot of other fresh foods. And so here, the problem is overstock, which we had more stock than we should have had in the store. And we overstocked a fresh item that perished and expired, and that even made the loss even larger. And so having prediction models that are able to detect and decrease overstock can cut the costs. And cutting that cost is also creating value. And so understanding how you can increase revenue or cut costs, how an application of AI maps to solving these business problems to a business or a company. In this case, either the store itself or the dairy company or the logistics company shipping the dairy between the stores or the farm itself, all of these factors. And I want to bring your attention to a different problem. We're not just talking about saving money for businesses. AI is extremely powerful as a tool, and it's already having a tremendous impact on humanity. And so when you have this power to make prediction machines that foretell the future, you always have to think about the consequences. And this is a huge responsibility for everybody who's interested in AI and wants to think and learn about AI and deploy AI. And in this case, losing milk and having it spoil has more effects beyond just losing that bottle or the money that was invested in this. Think about that. About 30% of dairy, between 15 and 30 is the number, is actually wasted. And so that's milk that is extremely expensive to make. How expensive? This is one glass costs this much of CO2 emissions into the atmosphere. It requires a lot of land. A lot of water is used to create every cup or glass of milk. And so this waste is really dramatic, and it goes beyond the farm or the dairy company or the supermarket. Every one of us pays the price for that. And what are the consequences? So this is a problem that if you can focus on and solve and share what you learn, and other people in other places of the world are able to improve the efficiency of their dairy companies and their supermarkets, this can have a tremendous impact on humanity, because the planet heats up, the ice glaciers melt, seawater rises, we have floods, and that creates misery for people. Floods are already happening, but then this stuff will happen a lot more in the future. And machine learning is one of the very powerful tools that we should be always thinking about deploying to solve our biggest problems. One of them being climate change. And so this is generally called time series forecasting. So if you have a list of numbers, let's say sales for each day, that is called a time series. And this is an icon I created for this kind of model, just to say that, we have previous historic data here in blue. This model is able to predict potentially how it's going to evolve in the future. Prediction usually requires a lot of data. So not just 4 data points, not just 3 examples. We'll need hundreds, if not thousands or millions of data points to be able to create good predictions. But these are all examples, and they're just symbolic. We've talked about ice cream. We've talked about milk. Think about every product in the supermarket. These are fast-moving consumer goods companies. They and their competitors always have to think about the different products, how much of them to stock in different stores in the city. So these are all business problems that need to be addressed. And this is value that you can create, I believe, for these companies and for their competitors. One example, I love interactive visualizations. So you can go to decision.ai, and they have a link called example. And they give you an example of 4 stores that you, let's say, own. And they've predicted the demand for a certain product. And you have a choice here. So you have to move this slider, and you choose to say, okay, do I supply 100% of the predicted value or less? And it gives you different results because it's a bit more complex of a problem if you're thinking about multiple stores. And so this is a real world example based on real data that I've enjoyed. One other domain where forecasting is extremely important is when you think about transportation, or companies like Uber or Lyft or Didi or Careem in our part of the world, ride-hailing companies, basically. Now, these companies also have sellers and buyers. They have supply and demand. And for them, predicting demand and predicting supply would lead to a better marketplace if they can predict them and then balance them using whatever tools that they have. So let's think about this. Let's say that a city is broken into 2 zones. And this one zone has 6 people waiting at 5 p.m., 6 people logged into the app and requested rides. But there were only 2 available rides here. Problem is the other region has enough drivers, but they're a bit far. So how do you solve this? This is a problem. 4 of these people will have to wait a long time to get a ride. And you would lose, your marketplace would lose a lot of money in this scenario. These riders would just switch to your competitor. So what these companies do now, what you can do at 5 p.m. is to say that, okay, this is a surge area. And when these drivers see that they can get more money by picking up passenger in this region, they would move. But this would take a lot of time if you only do it at 5 p.m. What you can do is that at 4 p.m., you can predict, you can have a forecast and make a prediction about how much traffic or how many people are going to be requesting rides at 5 p.m. And you have a lot of historical data to build that prediction. And so what you do is that at 4 p.m., this is the traffic that you currently have. And then at 4 p.m., you make a prediction of how many riders are going to be there and how many cars are going to be there. And so if there isn't enough cars to satisfy that demand, you do the surge pricing before 5. And so at 4, you incentivize these drivers to go to this area to satisfy this demand. That's what these companies and like delivery companies, food delivery companies, call shaping the fleet. And it uses forecasting or predicting demand and supply, and then balancing where there is a mismatch in that. You can think of other places where the same problem can be solved. So think about, let's say, hotels. So hotel chains or companies like Airbnb or Booking.com. If you think that or you forecast or you accurately predict that a certain city or destination will have more tourists visiting, then you have properties in that place, you can go to that city, let's say, and sign up more hotels for your platform or more properties to host these people. And so you can think about the problem in, the domain of, or the scope of hours if you're in ride hailing, or in weeks or months if you're in the hotel industry. The same problem also can be thought of in the domain of hospitals. And so if you're a hospital, you would want to predict how many inpatients are going to be visiting you, just to know how much to staff up your hospital and try to reduce how crowded the hospital is. Energy companies and utility companies can gain a lot from accurately predicting the usage on their networks and the demand and supply. And if you think of any business in terms of supply and demand, and you have enough data and ability to forecast them, you can create a lot of value. This concludes the second video in our talk about predicting and forecasting sales and supply and demand and the like using time series forecasting. Hope you've enjoyed it. Please subscribe and like, and let me know what you think and what other topics you'd like me to discuss. I have a few more ideas that I'd like to throw your way and applications that I'm working on for the next videos, but always willing, and I love to hear all your feedback. Thank you for watching.